And you'll let me know if, is it recording? Yes. All right, so we are going to go through SS3, so study set 3. And after the study set, I'm going to start reviewing for the midterm today, and then we'll finish up on Thursday. A couple comments. I just write notes to myself as they come up, as people ask questions. Something you're going to hear me say again is, so my other class, my Monday, Wednesday class had their first midterm last night. Yours is next Tuesday during this time on Zoom. And the biggest issue I had was several people still are not making everything into one PDF file, which starts becoming more of an issue when we get to the exam. So if you're somebody who's still like taking individual pictures and submitting like a bunch of individual pictures, please make sure you talk to me or send me an email, and I will send you the link to like a 1-minute video of how to make it a PDF. Because when you turn in your test, if it's not that, then we sit there awkwardly for 5 minutes while I watch you learn how to do it. And so it'd be much better if you learned how to do it this week before next Tuesday. Yeah. And the other comment, and I'll make it again probably in an hour, is your lab 4. Hopefully you have all started it. You were supposed to start it by last Saturday, which was, there's 3 parts to it. And the one part is you have to do a 7-day challenge. So hopefully you're all doing that, and we can talk about that more later. And then my note about Google was just because somebody had asked something, and it reminded me my other class had some question, and I could tell who used Google and who used their own brain, because the people who used Google all got it wrong. So anybody can post anything on Google. It can be a really good resource when you know how to use it, like how to differentiate. The students who approached the midterm last night as if it's like a real in-person midterm, they were done in an hour. And so something to consider as you approach or study over the next week. And so redoing the study sets, making sure you understand it and stuff like that. So, all right. All right, let's do this. So we're just the 3 subatomic particles. The one that's not in the nucleus is the electron, and you can just use the symbol. Same on your quiz. Proton is a little p with a positive. Nucleon is both protons and neutrons, so both of them, and they are considered the massive subatomics because they both are roughly 1 AMU. And again, an AMU is about 10 to the -24th grams. So when we're saying massive on the atomic scale, that there's no comparison. All right, for number 2, yeah, so your midterm will be all show your work. And so there might be a question like this. And so there could be multiple ones that you circle. So we're looking for the ones that are wrong or false. So A is okay. A is true. So the heavy subatomics are protons and neutrons. B is, in my humble opinion as a chemistry teacher, the most wrong statement there could be. As they do more and more research, the nucleus keeps getting smaller and smaller in volume. And so if it is a huge amount of mass, like almost all of our mass and almost no volume at all, its density is going to be enormous. In fact, if you take Chem 221, we actually do some calculations, and it comes out on the scale of like 10 to the 14th, so 100 trillion grams per milliliter. So 100 trillion times more massive or dense than water, which you might be like, oh, okay. But that's a number I can't fathom. All right, and then D is also wrong. So B, C, and D were all wrong, and that is because the nucleus can only be positively charged. And that's because it has the protons. And so nuclei are always positive charged. And again, I keep going unless somebody has a question. And it's okay if you got one wrong. again, I recommend using a different color as we go through this, and I highly recommend that you want to redo your study set. You don't have to print it out, just so you have your answer keys, so when you do it again, you can always check yourself. All right, our protons and neutrons tell us the mass number. So again, the mass number is the total of the protons and neutrons, and the protons tell us our element. And that will always be on your periodic table. So hopefully you've printed a periodic table. You need one that is there in front of you. And I've seen several of you have it up on the wall in front of you, which I'm envious of. So one proton puts it at hydrogen, and 2 nucleons would mean, when I ask you to show the symbol, I need at least that much. The full symbol does show the atomic number down below, but the H designates the 1, and that's what it's saying. So it didn't say you had to, you could give the name, that's the symbol, sorry. I changed the question and didn't read my question. The name would be hydrogen, and the mass number is 2. All right, for 10 protons would put us at neon, so Ne, and we add these 2 up, and that would be number 20, neon 22. So this is the other way that symbols are actually written. That's how they're always read. So 12 protons would put us at Mg, which is magnesium, and its mass number is the same. So these are not isotopes. They have the same mass, but they're different elements. So they're kind of the antithesis of an isotope. You can ponder that. There's a fancy name for these guys, but that doesn't matter. All right, 50 would put us at Sn, which is tin or Sanus, and then we add these up and you get 119. So tin, they put a dash. You didn't have to show the dash. All right, protons, neutrons, and electrons. So the atomic number is your protons. We'll just make a column. So 10 protons, neutrons, electrons. This one has 10 of each. So your mass number, again, you subtract the atomic number to get your neutrons. The mass number is 110. You're not going to see me use the Z again. I don't like this notation. That is the atomic number. I don't know who came up with this, but it makes no sense. They call the mass number the A number, but 48 protons, 48 electrons. Keep your protons and electrons equal unless I change them. We do get into ions later this week, and next week is about ions. So we'll all be changing them by then. And then we add this up and you get what, 50, 62 would be our neutrons. So when you subtract these, that gives you your neutrons. All right, tin is number 50. So 50 for each. And again, you take the 119, subtract the 50, and that gives you your neutrons. So 69. Copper is 29. And we subtract, so 34. Another quick comment is, sorry, I'm looking for one. So like cadmium, see my periodic tables had a lot of use. This number down below is the atomic mass. It is not the mass number. So different isotopes have different mass numbers. Every element has multiple isotopes. So you just go with whatever I give you. All these numbers have to be whole numbers. That's because to be a proton, it has to be a whole number. All right. So gallium is these two. Now, if we had an equal amount of them, we'd come out with 70, but this is where we use this number below on the periodic table. So gallium is 69.72. That's its atomic mass. Again, not the same as the mass number. So the atomic mass is an average based on abundance. And so it's always closer to the more abundant. If these were 50-50, we would get 70, but it's slightly closer to gallium 69. And make sure you read my question. I want to know how many neutrons are in the more abundant one. So gallium-69 is the more abundant. We subtract then the 69 minus 31. So our answer would be 38 neutrons, would be the final answer for number 5. I know there's a question like that on the quiz, so just make sure. And I did fix, Stephen told me I had the wrong date on the quiz, so it is due tonight at midnight or 11:59. That will probably happen again because of, again, Blackboard on my end is not intuitive. All right, the atomic number is your protons. You could also say electrons if it's neutral, which I think we are on this study set. Again, when we make ions, the electrons change. So that's why I always think of that in parentheses. The mass number is your protons plus neutrons, or you can say the nucleons. That's what the protons and neutrons are. When you subtract, that gives you your neutrons. When you add, you get the protons plus neutrons. And then if you think of the atomic number as the electrons, you get all 3 of them. And I know I didn't talk about that, but your study set does require, it is school, and it is really good for you to think and consider these. This is often called the total subatomic in chemistry when we're just looking at these. And so that question, I think, comes up again. All right, so for this symbol, atomic number is 15, protons is 15, electrons is 15. The mass number is 31, neutrons are 16. And then for the next one, to name the element, we're just looking at the lower numbers. So this is oxygen. Number 9 is fluorine. Number 21 is scandium. And again, becoming familiar, you guys absolutely should have a periodic table with names as a backup, but being familiar with them will help you to be more timely in being able to get things done. And if you're sincerely doing the work that's assigned, you're probably getting pretty familiar. You don't need to memorize the numbers, but when you look at CU, you should, in your head, just click, hey, that's copper. Any questions with the first page?
So when you ask for the, for us to name the element, you want the entire element name, not just the symbols?
Yes. If I just said, thank you, Spencer. If I just say, what is the element, I would take either, but sorry, on your studies or in your quiz, I ask you, that's why I underlined it on the quiz, like name the element, name the halogen. To get full credit, you'd have to write the name. And that's so simple now since you guys, yeah, and like here, the element name versus the symbol. So yeah, thank you for asking that. Anybody else? The other quick comment before I forget is I do eventually scan my answer keys that I make during class and I post them in that week's folder. So like study set 1 and study set 2, my answer keys are there because some people it helps them to visually go back and some people they actually like hearing it. And so I also post this, but all right. So it's all about magnesium. A is false. They have the same protons. So if they're both magnesium, they have the same protons. These are isotopes. So they do not have the same atomic, same subatomic because their mass is different. Their neutrons are different. C is the one that is correct. That 24 has 1 less neutron. And then D would be correct. They have different mass numbers. So these again are isotopes. You should know what that word, I keep using it. So iso is a prefix, shows up a lot in chemistry, but it means same protons, same element, and different neutrons. All right, the next one, similar chemical properties means same family. And so for A, we would have sodium and cesium. Yes, it's be in the same family. On B, this is one I did wrong in my other class. Yeah, so germanium and tin. C is strontium and barium. So they're both in the second column. And then D, the noble gases, helium and neon, would be the ones that are the same or similar chemical properties. Okay, number 11. So period 2. So the period is your row number. And then the alkali metals. So period is the row. And alkali metals is the first family. So column 1 or group 1. So this would put us at lithium. And again, the question Spencer asked me, you can just write LI, but if it's on something like your quiz or the midterm, you would want to write the full name for full credit. All right, period 3 noble gas puts us at AR. So that is argon. And the other reason I ask you to write names, especially at this point in the class, is where we go next week is naming or nomenclature. And so we're writing all the names out. So becoming familiar with them now will make next week much smoother. All right, the earth metals are in the second row. So this is calcium. I'm sorry, second column. And the halogens are right before the noble gases. So period 5 puts us down to I, which is iodine. So also being familiar with your family names. All the families have names, but, and again, you can write on your periodic table. This is one that I would have given out at a midterm, and the students would all write all their information before they started the test. Yeah. All right, the nonmetals are over here above the staircase. The metals are this whole side of the periodic table. Hydrogen is considered a nonmetal because it's a gas. I don't ask for which one it is, except maybe on this question. And then the ones that touch the staircase, so boron, silicon, germanium, arsenic, antimony, tellurium, they're the metalloids or semimetals. So this one's the nonmetal, and so that is hydrogen. On B, it is carbon. On C, it is fluorine. And on D, it is selenium. So some of these questions are really, they're not that hard if you've been doing everything. On 13, there was only one answer. Metals are shiny, and they would be malleable. This just means that they bend. And so non-malleable means not bending. Luster just means shiny. All right, now we move into electrons. So A is wrong, so that is false. The subshells have different shapes. So the subshells are the SPDF that I wrote behind me, and the different shapes give them different energy. So remember, S is just a simple circle, so that is a really mellow, lowest energy. When we get to D and F, where we get the 4-leaf clover or the 8-leaf clover, that's going to have much higher energy. S is a sphere, so that is false. And then C is true and D is true. So third shell, when N equals 3, we have the 3S, the 3P, the 3D. And we did this last week. That gives you 9 orbitals, which each orbital holds 2 electrons. So that's where I got the 18 electrons when N equals 3. All orbitals accommodate 2 electrons. So the same number is 2 electrons. And Spencer, this is back to the question you were asking me earlier, This is the spin. We show the spins as arrows just to denote it, but it is clockwise and counterclockwise. So there's only 2 spins, so 2 is the maximum. All right, 15, back to this, SPDF. You know, it's really handy to write that down. You can absolutely have notes next week because I can't control that. But if you're flipping through all your notes, having it like organized on one thing, but just SPDF, in fact, just writing it 1357 when you get to that part of the test. And again, the SPDF is your subshell designation, which is the shape. And this was last Tuesday's lecture. And then Thursday, I covered it again real fast, but on Thursday, somebody asked me when I did number 17, like the practice of those, and that was last Thursday's lecture, if you want to go back over it. The 1357 is the number of orbitals. And then every orbital, you double it for the electrons. So D has 5 orbitals, so 10 electrons. F has 7 orbitals, 14. D would again be 10. And then the second shell, when n equals 2, we have the 2s and the 2p. So we'd have 4 orbitals, 8 electrons. All right, naming the element. There's 2 ways you can get the answer. One is you can add up the superscripts. So 2 plus 2 plus 2 is 6 electrons. So this is carbon. Or, that's going to get tedious, you can just look at the HEO. So this is HEO. That question comes up later, so I'll talk about it then. But it's the last subshell that has electrons. Does not have to be full, but has an electron. And once you know the pattern on the periodic table, again, I recommend you label your periodic table. Some of the students in my other class have either laminated so they can write on and then erase it, or they just printed multiple ones so they could see that they felt comfortable with it. So it's ending with 3s1, sorry. So here's my third row, S block, first box would be 3s1. So this is Na or sodium. Again, why you want to be familiar with your elements. So when I say sodium, but write Na, you'll know what's going on. So the P's, the S's are here, the P's are over here. So 3p5 would put us at chlorine. So you want to be careful, the first row does not have any P's. So 3p5 is chlorine, and then 4p3 would put us at arsenic. All right, so a question that always comes up. You can use the shortcut. So if you did that on A, you could just write neon. So the shortcut is you start with the noble gas, and the closest noble gas to neon is neon. If the other way you can do it, I would prefer if you all did it with the shortcut, because that's how everyone does it. Neon, you would start at 1, and then you go to 2, and then you go to 2s and 2p. And that would give us our 10 electrons. I'm going to do the rest with the shortcut. So just a reminder, and again, this was last Thursday's lecture. So if you're still having trouble, go back and listen to that. Or Thursday, I'll have lots of office hours. We're going to do practice with this today, and so hopefully you'll start picking it up. So you would find aluminum. You go to the noble gas that comes before it. And then after neon, neon's number 10, you come to 11, and you're always in the S's after the noble gas. So we have the 3 S's, and then we come here to the 3 P's. So it's going to be neon, 3s2, 3p1. And I'm going to go through that with each one of these. So for potassium and titanium, you would start with argon. So potassium, argon, potassium, titanium, the previous noble gas. After argon, 18, you come to 19, you're going to be in the 4th row. So 4s1 would be potassium. To get to titanium, the middle is the D's. So potassium's 4s1. For titanium, we go through both of the 4 S's. And then the D, the whole trick with the D's is they're always one number off the row number. And again, that has to do with the D orbitals have so much energy that you actually start the next S's. So the 4s is bigger, but it's more mellow because it's just a sphere. So even though the 3D, the 3 tells us it's closer in, it's a smaller orbital, the D is a crazy pattern. So the order the periodic table goes in is based on the energy of the orbital that the electrons are in. So that's writing these out. Showing the box and the arrows, the SPDF, the number of orbitals is the number of lines you draw. So S, there's my S, I would draw 1 line. This is the number of arrows. So again, the arrows are the electron spin. And it's just how we designate it. For P, you will always show 3 lines and you will bracket them to show they go together. That 1 electron can go anywhere and it can spin either direction. You can draw full arrows or you can draw half arrows. All right, for potassium, we just need 1 arrow, 1 line. In titanium, we show the 4s. And then for the D, we show 5 lines. I know it's 5 lines because D's have 5. And then you bracket those 5 to show me you understand they all go together. They are all equal. It just has to do what angle they're at in space. These 2 electrons, so these are the rules. They cannot pair if they have different possibilities. So they do not pair until we get 1 in each of these. And they have to spin in the same direction. So you can put them in any 2 orbitals you want. You can put them next door to each other. It doesn't matter. You can spin them both up or both down. It's a law of magnetism. And again, what laws mean is they don't fully understand why, they just know it's true. So I teach a kids class and it's great how the definition of law is it's fact. It's fact until we learn more information. So right now that's a law. And so that's where we're at. Any questions?
I have a question about potassium.
Yeah.
Okay, so I think I messed it up somehow, but I got 3D1. Is that even possible? Not 4S1.
So first of all, anything's possible, but it is not. Well, I didn't write the question well, but we're doing ground state, so we always go lowest energy. So potassium would be here in the 4s. The 3D is over here. And so what you did, Stephen, is rather than following on the periodic table, you said, okay, after my 3Ps, I go to 3D. But you always have to go through the S's first to get to the D's. Hopefully that helped a little bit. So the 1As are always either 2s1, 3s1, 4s1, 5s, 6s. The D starts at scandium. If the electron were excited, anything is possible. You can go to the 6f if you wanted to.
Thank you for answering that.
You're good. Anybody else? All right, got 1 more page. Used to be 2 more pages. The last page is a tough page, and that is in your lab. And your lab is actually due Saturday because the 7-day challenge, you have to have done 7 days, and maybe you'll even continue. That page in the lab, after going through this and actually doing some of the practice on the practice exam, that should hopefully make that page not as bad. But you can absolutely come to office hours to ask questions or to go over it to make sure you got it. And I do have a Saturday morning office hour. You guys don't have stuff due Saturday normally, so my other class, though, does use it pretty frequently. All right. Unpaired electrons. Actually, we're going to go back a page. I made a note to myself because I wanted to do something else with these that I drew out. And it is the unpaired electrons comes from the diagrams. So these two different types of diagrams, what I call the NLX, and again, that's what I'll call them on the test, and these are the box and arrows. I'm sure you figured that out. They have so many different names, so many funky names, but the unpaired electrons are an arrow that does not have a partner. So if I asked for aluminum or potassium, they would each have one unpaired, and titanium would have two. So it's the arrows without a partner. Neon would have 0. If I'd asked, so that's like what the next question is. The valence is any electrons after the noble gas. And that's what this notation shows us nicely. So aluminum has 3 valence. Potassium has just 1 valence. And titanium would have 4. And neon, it's your interpretation. You could say 0 because there's nothing after the noble gas. And some periodic tables actually put a 0 over that column. And some people would say, well, it's everything after the previous one after helium, because this is helium. And so they would say it's 8. I don't care. But I didn't ask you this on this question, but this is a really good question to visually see it. And so realize, like on your quiz or on your exam, you can always get these answers from going back to this. You don't have to draw the whole thing out, but and then I'll show you also on the periodic table. The HEO is the last orbitals that have any electrons. So for titanium, that's the 3D. For potassium, that's the 4s. For aluminum, that's the 3p. And for neon, it would be the 2p. So it doesn't mean they're full, it just means it has an electron. And that question comes up on the next page. But what I just showed in green for each of these questions was just an extra question because it's a common question. Again, you guys have an advantage because my other class, they just had a test on some of this stuff. And so I know where all the questions are. So with that, you can always go through drawing it. And some students actually like doing that because it gives them comfort. And the students who do that do get it right. If you become pretty proficient, it's actually just as fast. You can also just look at your periodic table. So for fluorine, to get to neon, neon's going to be where it's completely filled. So fluorine would be 1 away from this. So it's going to have 1 unpaired. Sulfur will have 2 unpaired because it needs 2 more to get to argon. So you can ponder that. So fluorine would have 1, sulfur would have 2, calcium would be 0. And that is because it's at the end of the S block. So its electrons are both paired. And zinc is at the end of the D block. So if you're at the end of a block, you end up with 0 unpaired. And there is a term I did not use last week. These two, I'm hesitating because online there's like different definitions out there, but traditionally diamagnetic meant that there's no magnetism at all. There are no electrons that they all are paired up. If you have unpaired electrons, I don't know why they called it this. It has to do with the root of dia and para. Paramagnetic means you have unpaired electrons, and so you have a magnetic moment. When you only have 1 or 2, you need a really strong magnet. If you have a lot, like 4 or 5, so iron, cobalt, and nickel are the only elements that are going to stick to your refrigerator. So the ferromagnetism is actually these guys. But that's because of the d orbitals too, and that allows them to do pretty cool stuff. The ones under them are not as common, so I don't know enough to be able to answer that. All right, Number 19. You're looking at the ending 2p4 and 2p5. They're not the same. They'd be next door to each other. That would be oxygen and fluorine. S2 and P2, again, not related. Two different areas of the periodic table. C is our answer, so the 2s1 and the 4s1, they're in the same family. In fact, that would be lithium and potassium. All right, and then D, also not related. We have 2p and 3d. They're not in the same area of the periodic table. So this is, again, same family. All right, 20 and 21 are asking similar things. Aluminum is in the P area, potassium S, sulfur P, gold is D. The difference is on 21, it wants the shell number also. So for the HEO, and that's what HEO stands for, highest energy occupied orbital, neon would be in the 2p. So if, like, for aluminum you said 3p1, that's fine. But this just wanted the shell. I'm sorry, this just wanted the subshell. This one's the shell and subshell. Cesium would be the 6s. So cesium is CS. And it's the first one. Cesium is the element that is used, that has defined what a second is in time. Arsenic is in the 4Ps, and zinc is in the 3Ds. So that's what HEO is, and that's just looking at your periodic table. You find zinc, it's in the D block, and the Ds are always just one row off. Again, you have the advantage. You can go back and rewatch the video. You can watch all sorts of videos if you want. I don't watch any of the other videos because they often do things that aren't quite right. But number 22 has a star, only because it's a little bit more challenging, but does require you to think a little bit. Isotope means different neutrons. We're talking about electrons, so it's still the same. So it's still one. You could just said the same, or you could write out the same thing. Nothing changed. So that's actually an important question once you see that. So this study set really, actually these first 3-4 weeks covered the periodic table. We're going to get into ions, and that should even hopefully make you look at the table with new respect. All right, the family name, alkali metal. Learning the names would just mean when you take the test, you're not there shuffling around, always double guessing yourself. Cobalt is in the middle, and those are called the transition elements, or the transition metals is what I sometimes call them. So that's all the D area is called the transition. The ones, the F area, I talked about that, they're the rare earth metals. You can see this periodic table has a lot of love, has a lot of use to it. And I have like a gazillion at school, so I have to go get another stack of them. All right. And then 24 and 24. So 20 electrons must mean 20 protons. And so that would be calcium. We add these two together. So again, mass number, atomic number. So mass number on top. I leave the atomic number as optional because the symbol Ca means it's number 20. That always goes together. All right, radon is Rn. It is a gas, and it is radioactive. So everything after lead, after bismuth, is unstable. The nucleus just has too many protons. and so it loses energy. So that's E equals mc squared. That mass becomes energy. And so when it loses mass, it loses it as energy, and you get this huge amount of energy coming off. It gives it off as an alpha particle, which has a mass of 4, and alpha particles create a lot of havoc. It's a gas, so it gets trapped inside you. So outside, our skin actually protects us from alpha particles, but when radon is inside of you, it can't escape. And so that's the big hubbub about radon. You shouldn't be worried about radon. If you smoke, you're getting a lot more issues. And you're also getting exposed to a lot more radioactivity, because the soil where they grow tobacco in like the southeast has a huge amount of radioactivity issues, just because of the minerals that make it up. The mass number is right there, so it's 211. And again, you go with whatever mass number I give you. On a lot of the periodic tables, like mine, which is an older one, it says 222, and it's in parentheses because that was the only one that they had made at that time so far, but there are a lot of other ones. Silver is Ag, argentium, and what we know about silver is number 47. So this is back to Stephanie. You were asking me if you subtract the 47, which we can think of as 47 electrons, we would get 110, and that would be our mass number. That would be our nucleons, our protons plus our neutrons. So it would be silver 110. Right, and then this one, nucleons, is the mass number. So Be is beryllium, and then it is number 4. Right, and then the little chart, you have one of these on your homework. He is helium. Sorry, on your quiz. I need to rename those. Helium is always atomic number 2. You have to go with my mass number in this question. So the 4 on the periodic table, again, is the atomic mass. The most common isotope, the most stable isotope, is helium-4, but there are others possible. And this question is about helium-3. So the protons are 2, that's why it's helium. It has only 1 neutron. It's not very stable. There's an ideal ratio of protons to neutrons. This one does not have it. So again, it would be radioactive, which just means an unstable nucleus. All right, nickel is Ni. Nickel is number 28, yes. So 28 protons, we subtract 32 neutrons, and so you can put the 60 if you want. Right, atomic number is your protons, and number 18 is Ar, and the 37 again is just this isotope. We subtract, we get 19 as our neutrons, and that is argon. All right, and then this one we have to subtract, so we get 38, which is Sr. If you want, you can put the 90 if you can fit it in your box, and this would be strontium. Strontium also has radioactive isotopes, and our Marines, Air Force, Navy, the ones that all have the I guess they all have helicopters, Army too. So strontium is used to calibrate helicopter blades. Something to do with the radioactivity in it. So how often the nucleus decomposes is a counting way, and it helps the blades to do their thing. So I had a student who that actually was his job when he was, I can't remember if he was Army or Marines. Questions? That's it. All right.
I have one, but it might be a little off topic.
Go for it.
So I was watching a video, and they were saying that hydrogen 3, hydrogen 2, hydrogen 1 all have very specific names.
They
Hydrogen
do. They're the only ones that are named. So it's protium,
Okay.
deuterium, and tritium.
Okay, I was worried that we were going to have to eventually name all of these things.
No.
So those are the only ones that have a specific name for.
Yeah, and I think this goes back to the Manhattan Project that they named them.
Oh, okay.
And so if you get really geeky, you go to New Mexico and there's the tritium site, which is where they dropped the first atomic bomb. You can't get anywhere near it, but it's there. That's where the first atomic bomb was dropped. But you can go to White Sands National Monument, which is freaking amazing. It's the only place. So all the sand on this planet is silicon dioxide, so silicon and oxygen. But if you go to White Sands in New Mexico, it is selenium dioxide. So I actually have a sample of it. You can camp there overnight. And so the sand is white. And the only rule when you camp is if you see anything metallic, don't touch it, and you have to report it because it's also a bombing range. And so when they're bombing, you can't camp there. But anyway. That's not slightly off topic, but it's really cool, and I recommend it. New Mexico's got really beautiful scenery too. And then the weirdest part, so there's these big sand dunes. It's like in the middle of nowhere. I was walking ahead of my friends, and then I came back down the sand dune because I thought I was hallucinating, and I saw a camel. Somebody had a pet camel and took him out every Sunday to walk in the dunes. So a full camel, like my Nick. You guys will meet Nick the camel very soon. And so it's really bizarre. All right, so the quiz, I will answer questions later, but we're gonna do practice review, and that will probably answer maybe some of your questions on the quiz. And it is due today by tonight. I do have an office hour tonight from 6 to 7:30 if you have questions on it, or if we get done early today. But it's really not too bad of a quiz now that we went through that, or it shouldn't be. Sorry, I thought it's a good bonus question. All right, so we're gonna do some review because the first 2 pages will also help you with your take-home quiz today. And I'm gonna stop recording, so this is a separate video. And then I will start again.